The current through this inductor is given by the piecewise function that you see given here. So is of t is defined by this piecewise function. So we're going to write the equation of each section of the graph. So for t, now for 0 less than equal to t less than 1 millisecond, the equation is a straight line, so I will be mt plus b. So m is the slope, which is the rise over run. So the rise is 5. So the rise is 5, and so this is in amps. So the rise is 5 amps divided by the run, which is 1 millisecond. So it's 5 amps per millisecond. So I will be equal to 5t, and t is in millisecond, plus b. So now we need to find b, and we know that when t equal to 0, I equal to 0, so 0 equal to b. So that means that section of the graph, the equation is given by I equal to 5t plus b, and amps. And then we have to note that the time is millisecond. Okay, now so then the section between, so that's number 1, that's section 1. So section 2 is when we have 1 millisecond less than t less than 2 millisecond. The I of t and that area is 5 amps. Now that's section 2. Now section 3. So section 3, that is the section between 2 millisecond less than t less than 4 millisecond, and the equation of this section, I of t, is in the form still mt plus b. So let's find m. M is so the function is decreasing, so it will be minus 10 divided by the run, which is 2 millisecond. So that means we have negative 5t plus b, and remember t is a millisecond, so we need to find b. So how do we find b? We know that when t equal to 3 millisecond, that means I at 3 millisecond equal to 0. So that's negative 5 times 3 plus b. So b equal to 15. So the equation of the section is negative 5t plus 15 Okay, and the t is in millisecond. Okay, so to do this correctly, t is 3 milliseconds, so I'll have negative 5t plus 15 amps. So that is number 3. Let's do section 4. So section 4 is when 4 is less than or equal to t, less than or equal to 5. And then for this section, the current I of t is minus 5 amps. And then the last section, section 5, is let's not lose track of the fact that t is a millisecond. So I have 5 milliseconds less than or equal to t less than or equal to 6 milliseconds, and I of t is equal to, so this is session, so this was session 4 and this is session 5. Okay, so I'm going to copy this, session 5. So let me paste it here so we could look at it. This over here. So for that section, it's also mt plus b. So the rise we have as an increasing function. So the rise is 5, the run is 1, so 5t plus b. Right, so that's I of t, and we know that the slope is amp per millisecond. So for I equal to 6 milliseconds, which is 5 amps by millisecond, times time, which is 6 milliseconds, plus b. All right, so that gives me negative 30. That's b. So 30 amps. So I of t for this case is equal to 5t plus minus 30 amps. Okay, and still keep in mind that the time is a millisecond, so we can put it together. So I of t is 0 when t is less than 0, then is 5t when 0 less than equal to t less than equal to 1 is 5 amps. Between when t is a millisecond still, right? So let me put millisecond here. So 1 millisecond less than equal to t less than equal to 2 milliseconds, and then the section 3 is section 3 was negative 5t plus 15, negative 5t plus 15, that's 2 milliseconds less than equal to t less than equal to 4 milliseconds, and section 4 is 5 minus 5 amps, where 4 milliseconds less than equal to t less than equal to 5 milliseconds. Then we have 5t minus 30 when 5 milliseconds less than equal to t less than equal to 6 milliseconds, and 0 when t is greater than equal to 6 milliseconds. Now that is the current. Now we need to find the voltage across the resistor, so across the inductor. So the goal is to find the voltage across the inductor. Okay, so let's find that. Let's find the voltage across the inductor. Now we know the current to the inductor. So to find the voltage, what do? We know that for an inductor, I to the inductor is the integral of the voltage, VL of t is equal to L di, the current to the inductor divided by with respect to t, and let's say that L equal to 2 millihenry. So let's find this voltage. So we know that we know the current, so we could just find the voltage by differentiating the current. So for 0 less than equal to t less than equal to 1 millisecond, the VL will be L d over dt of 5t. So that gives me 2, so 5 times L. So because when I differentiate 5t, I am getting 5. So I am going to get 5L. Okay. So that will be the voltage across the inductor. So in many applications, for example in DC to DC converters, the current to an inductor in a circuit may be a piecewise function, as you can see on the screen. So what we wanted to do is to learn how to find the voltage across the inductor given in the circuit here as a function of time, given that the current is a piecewise function. So we know that the current through an inductor cannot have discontinuities, right? So because if you look at this, one of my previous videos where we talked about the voltage across the inductor and the current, the voltage across an inductor and the current through the inductor, and similarly for a capacitor. We learn how to so the goal of this example is to find the voltage across an inductor given the current, which is a piecewise function. Okay, one common application where you can see where the current through an inductor is a piecewise function is an example DC to DC converters. So for example, in a buck converter, the current through the inductor in the buck converter is a piecewise function. So when the current is a piecewise function, now what is the voltage, right? So the amplitude there is 5 volt. So what we wanted to do is to find the voltage, right? So unit is volt, right? So volt, that's the unit of the voltage. Okay, so what we wanted to do is to find the equation of the current to the inductor for each interval of time. So for example, when 0 is less than equal to t less than equal to 1 millisecond, then what is the equation of the current? So call this number 1. So for that, we know that the equation is a linear, it's a line, so we can write that as mt plus b. Now we need to find m and b. So m, which is the slope, is the rise, which is 5, divided by the run, which is 1 millisecond. So it's 5 times 10 to the 3. And let's find b. So I of t in this case is equal to 5 times 10 to the 3 t plus b. And then we know that at t equal to 0, I mean I of 0 will be 0 plus b, which is 0. So the current for that section from 0 to 1 millisecond is 5 times 10 to the 3 t. So I of t, so is of t equal to 5 times 10 to the 3 t when 0 is less than equal to t less than equal to 1 millisecond. So that will be the first one. Now let's do the second one for section 2. So this is for section 1. So for section 2, when minus so 1 millisecond less than equal to t less than equal to 2 millisecond, I of t equal to 5 amps. 5 amps, right? Oh, I'm sorry, the unit is amps. Okay, so the current through the inductor when t is between 1 and 2 milliseconds equal to 5 amps. Now let's find the equation for section 3. So that's section 3. So for section 3, we have 2 milliseconds less than equal to t less than equal to 4 milliseconds, and the equation of the line there is still is of t, which is a line. So mt plus b. Now let's find the slope. So m is the slope, so which is -10 divided by the run, which is from here to here, which is 2. So 4 minus 2, which is 2. 2 times 10 to the -3. So that gives me -5, 10 to the 3. Okay, so and then what is b? Let's find b. So we know that is -5 times 10 to the 3t plus b, which is is of t. Then I know that 3 milliseconds. So I is 3 milliseconds equal to -5 times 10 to the 3 times 10 to the negative, so 3 times, so 3, let's do 3 milliseconds, 3 milliseconds plus b. So that gives me -15 plus b. I know that is equal to 0. So b equal to 15. So for this section, is of t is -5 times 10 to the 3t plus 15 amps. That is 2 milliseconds less than equal to t less than equal to 4 milliseconds. So now for section 4, that is between 4 milliseconds less than equal to t less than equal to 5 milliseconds. So is of t is equal to -5 amps. So now let's look at section 5. So section 5, that's section 5. So for section 5, what do we have? We have so you know what, I could just copy this down there so we can all look at it. Okay, so I'm gonna paste it here so we have it in front of us. So now section 5 gives me what? Section 5, we have negative, so the time is 5 milliseconds less than equal to t less than equal to 6 milliseconds. So is of t, we know that is equal to still mt plus b. So let's find m, the slope, which is the rise, which is 5, the run, which is 1 millisecond, 1 millisecond. Okay, so it's 5 times 10 to the 3. That's the slope. Let's find b. So is of t, which is 5 times 10 to the 3t plus b. So is of let's plug in 106 millisecond will give me 5 times 10 to the 3 times 6 millisecond plus b. So that gives me 30 plus b. At 6 millisecond we have 0, so b equal to -30. So that means is of t for this interval is 5 times 10 to the 3t minus 30 times, where 5 millisecond less than equal to t less than equal to 6 millisecond. So to put it all together, we know that I of t is equal to 0 for t less than 0 and 0 millisecond if you like, and then is 5 times 10 to the 3t, 0 less than t less than equal to 1 millisecond. Then we have -5 times 10 to the 3t plus 15 when 1 millisecond less than equal to t less than equal to 2 millisecond. No, so this one is from 1 to 2, that's 5 amps, and then is -5 times 10 to the 3t plus 15, that's what we found. That is 2 millisecond less than equal to t less than equal to 2 less than equal to 4 millisecond. And then we know that is -5 amps from 4 millisecond less than equal to t less than equal to 5 millisecond. And then the last one is 5 times 10 to the 3t minus 30 and 5 millisecond less than equal to t less than equal to 30. Well, 6 millisecond, and a 0 for t bigger or equal to 6 millisecond. So we applied that to this inductor circuit. All right, so let me copy that. No, I'm just gonna copy this, and that's what we apply to this network. Okay, So that's the current. Now we want the voltage, and then we know the inductor value, L equal to 4 millihenry. So we know that the voltage across the inductor, V L of T, is L, the rate of change of the current to the inductor with respect to T. So I'm gonna do this for each interval. All right, so for a 0, for T less than or equal to 0 millisecond, then is L times 5. So L times 5, because when we differentiate, so L d over dt of 5 times 10 to the 3t. So that gives me L times 5 10 to the 3t. So L, which is 4 millihenry, times L is 4 millihenry times 5, okay, times 10 to the 3. So that gives me 20 volt when the time is between 0 less than or equal to t less than or equal to 1 millisecond. So as you can see, we are going to differentiate. So when I differentiate 5, I get 0. So it's going to be 0 here for between when t is between 1 millisecond less than t less than 2 millisecond, and then it's going to be negative 5 times 10 to the 3 times 4 10 to the negative 3. That is equal to negative 20 volt. 2 millisecond less than or equal to t less than or equal to 4 millisecond, and then between 4 millisecond and 5 millisecond is going to be 0 because it's constant. So when you differentiate negative 5 with respect to t, we get 0. So that's for 4 millisecond less than or equal to t less than or equal to 5 millisecond, and then we have 5 times 10 to the 3 times 4 10 to the negative 3. That's also 20. That is 20 volt between when t is between 5 millisecond and 6 millisecond. Okay, so that's the voltage. The voltage across the inductor with respect to t is 0. For t less than or equal to 0 is 20 volt. When t is between 1 millisecond less than or equal to t less than or equal to that's 0 times 1 millisecond, and then it's going to be 0 between 1 millisecond and 2 millisecond. Then is minus 20 between 2 millisecond and 4 millisecond. Then becomes like 0 again between 4 millisecond and 5 millisecond, and it's 20 volt between 5 millisecond and 6 milliseconds, and then the 0 for t bigger or equal to 6 milliseconds. So I can sketch this function. So when I sketch this function, so let's say 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5. So is 20 volt. Let's say 20 volt up to there. 20 volt. And then is going to be 0 volt. And then it goes down 1, 2, 3, 4, 5. It goes down to -20. So -20 between 1. So it's 0 here. So it's 0 here. And then what is 1 millisecond? 2 milliseconds. It goes down to here until 4 milliseconds. And then it goes back down to 0 between 4 and 5 milliseconds. And then I go back to 20 between 5 and 6 milliseconds. And then 0 after all, right? So t in millisecond. So that is the voltage across the inductor, right, with respect to time.